So here we're going to find the slope, and it's just the change in y over the change in x, right? The rise over the run. And I kind of hate the formula, but it's the change in the y's, so y2 minus y1 over x2 minus x1. So we're just going to plug that in. So we're going to take the 3 plus h squared minus the 9, and then on the bottom, the change in x, x2 minus x1. So that's y2 minus y1 over x2 minus x1. And then we're just going to keep simplifying. The big trick here is don't distribute that 2 over that plus sign. Addition and subtraction are they're not forgiving, not nearly as forgiving as multiplication and division. So this has to be multiplied out. It doesn't equal 9 plus h squared. There's going to be a big middle term in there. And so when you FOIL it, you get it's 9 plus 3h plus another 3h plus h squared minus 9 all over h, which is 9 plus 6h plus h squared minus 9 all over h. So yeah, so notice that when you do this, you get that extra 6h in there. So it's not just 9 plus 6h squared. I see that every day. Don't do it. Like, just when you see a plus or a minus, kind of hesitate. Like, can I really do that, or is that just wishful thinking, right? So when this simplifies, the 9's go away, and you just get 6h plus h over h. And then since every single piece is divisible by h, you can divide by h. But safer is because you're factoring out an h, reverse distributing out that h, so that the h's cancel because it's now multiplication, right? And we can, h divided by h is 1, and it's safe to multiply and divide by 1. And there's your slope, which is exactly what they said, which they told us it would be. Check. All right, so we've got this point P, and I'm just gonna, I don't know what it is yet, so I'm gonna call P some xy. And I want to show that the slope through that point and this point is that. So I'm just going to do it, right? I know how to find slope. It's so it's the y2 minus y1. I think I'm actually going to, you can subtract in any order you want. I'm going to choose to do this one first. So I'm going to do the y minus 1/2 over the x minus 2. And that's your slope, right? The y is subtracted over the x is subtracted. And they tell me that they need that slope to equal -1 over 16. So there's my equation, but it's a little ugly because I have two variables in it. And so I can't solve with two variables. Hopefully they gave me another equation, so I have two equations with two unknowns. And they did. Because my point is on this graph, I know that the y value equals 1 over x. So I'm going to substitute in 1 over x for the y. So basically that xy was x comma y, which is 1 over x. And so now I just need to solve this. So you have many, many plans of attack. Some people like a good cross multiplying, which is fine with that equal sign there. You could do this times this equals that times that. In fact, I think I'm liking that. When you have fraction equaling fraction, it's a pretty darn nice way to go. So I'm going to say that x minus 2 times -1, x minus 2 times -1 equals 16 times that mess. I'm making a mess. 16 times 1 over x minus 1/2. Now the whole reason that works, a lot of teachers are veering away from that, but you're making common denominators, you're multiplying both sides by the denominators, and they're in essence canceling. But it's so fast when you have fraction equaling fraction that I kind of like to do it. So I'll just distribute, and And so I'm here now. And now I don't like that x on the bottom, so I'm going to get rid of that by multiplying both sides by x. I'm going to fraction bust here, and I'll let that x distribute to both sides, and it'll get rid of the fraction like I planned, and now I'm here. So that was this guy distributing and knocking out that x multiplied by both sides. And so now it's like, well, what came out of this? What fun is in store for us now? We have a quadratic. We know how to solve quadratics. We kind of like them with one side equal to 0. We're going to cross our fingers that it factors. So I'm going to send everybody over to this side. So add x squared, subtract 2x, add 16. Ooh, I think it's going to factor. So that's x minus 8 times x minus 2. So an 8 and a 2 will make that thing equal 0. I can't box it yet. Maybe there are extraneous solutions. So I have to check to make sure none of these made a denominator 0. So let me take a look. If x, like an 8 and a 2, they're not going to affect that denominator. So I think, but that 2 would make that denominator equal 0. So the 2's got to go, because it's okay to have a 0 on top, but it's not okay to have a 0 on bottom. Okay? No. So the 2's got to go, so the x equals 8 is our answer, or the x part of our answer. And if you want the full ordered pair, when x is 8, the y is 1 over 8, because the y is 1 over 8. And that should work. If we felt like it, we could now take those 2 points, 8, 1 over 8, and 2 comma 1 half, and check to make sure that the slope really is negative 1 over 16. Not sure I really feel like doing that, but we could. Why not, right? We'll take the changes in y's, so 1/8 minus a half, over the change in the x, so 8 minus 2. So that's 6 on the bottom. The top is 1/8 minus 4/8, which is negative 3/8 over 6. If I multiply top and bottom by 8, I get negative 3 over 48, which, thank goodness, is negative 1 over 16, which is what they wanted. Yes! Happy. Awesome.